So join is a proper kind of a proper name. It's a procedure that you can use in ArcGIS. They form temporary relationships between tables using relational database management system concepts, basically the primary key and the foreign key. So here, bullet number 2, the tables must share a common field or a key where those numbers have to exactly match each other in order for it to work. While the join exists in ArcGIS, this program treats both tables as if they were one single table. The original data is not affected, it's not written to. You can remove the join when it's done. And one of the things that I usually do when I join tables is I will export that information as a new shapefile or new feature class so it is completely separate from the original data, but it becomes one that then I can modify and analyze as I see fit. And so you use just the normal export function from the table of contents. Right click on the data set while it's joined and export it, and then you will have a completely new spatial data set that has all of the joined information together stored in a new file that you can then do with as you please. Joins can be one-to-one, meaning there's a one-to-one match between the source and the destination table. One record in the destination table exactly matches only one record in the source table. So this is known as cardinality of joins. This is a cardinality one-to-one. So the rule of joining is that each record in the destination table must match one and only one record in the source table. And this can be, as we just saw, the one-to-one relationship, one-to-one cardinality. One record in the source matches one in the destination. A join can also be what we call a many-to-one cardinality, where one record in the source table matches many records in the destination table. So the way to think about this is using the example here with the U.S. counties on the left and the attributes of U.S. states on the right. We have multiple counties in Washington state, and we're going to apply the information from the states table to each county. So that's, again, the cardinality many to one. Okay, there are many records in the destination table, but they all match to only one record in the source table. You can join as many tables together pretty much as you want. You cannot join to a joined source table. What we can do here, we can have destination, our original data table, matched to source number 1. Then we can join that source 1 to source 2 and bring them together one at a time. All right, and build then a very large data set. As long as we have the primary key foreign key relationship going on between each of these pairs, we can keep adding on more and more data, and you can wind up with a really immense data set that can be kind of a problem to manage, but it can be very useful for doing spatial analysis to combine information from many different sources, as long as it's all focusing on the same enumeration unit, the unique IDs in the original table. Then you can do some really cool stuff with joins, bringing together different forms of information. A relate is something that's similar to a join, except that with relates, the tables remain separate in ArcGIS. They do not get physically combined into a single table. When you select things in one table, they're going to be highlighted in related tables. So for example here, we're selecting the New England states in one table that's been related to another. So the U.S. states table is related to congressional districts of the 110th Congress. When we select the state names in the states table, the relate function will highlight all of the entries in the congressional district table, and it will. What it's essentially doing here is it's pulling out who are the representatives from the New England states, and then you have that selected as a set. So we're selecting 6 out of 51 states if we count Washington D.C. as a state, and if we select the New England region, that gives us 22 out of 437 representatives for the 110th Congress. Okay, so that's just an example of what a relate does. And you can see that there's some slight advantages to doing it this way rather than bringing them together as a join might do. It keeps them separate, and that's the main difference. It doesn't make as complex of a huge data set in the end, and you can you can work in one and it selects things out for you in the other, and you can map both in different data frames or in different ways if you need to. So it's just a version of linking tables together, but it does it differently than a join. So to summarize the ideas here, you need to think about it as destination source relationships. So for joins, our destination source relationships are one-to-one, many-to-one. For relates, one-to-many or many-to-many. So we can have, for relates, we didn't really discuss those two in too much detail, but the one-to-many relationship would mean you have one entry in the source table matching many entries in the target table. So the example of the representatives fits into that pretty well. We can also have many to many, so you can select many things in the original table and it will select many things out of your linked source table. All right. So when you need to think about cardinality and which way to go, here's what you're limited to, and think about the advantages and disadvantages of either type of a link, the join and the relate. They both have advantages, they both have disadvantages, and you may have a preference for one or the other. I typically will use joins more than I will relates. That's kind of a personal preference. You can use either one you need to get the job done if it's appropriate. We extract information from a table in a couple different ways, but one of the main ways is by formulating a query. A query is basically a question that you ask of the data set, and it can only give you responses based upon the variables that are contained within the data set. So here's some examples of things written out in English. How many students have a GPA greater than 3.5? If you have a column of information with GPAs for students, you can structure the query and say, that variable, give me all the records that are greater than 3.5. And that will be what gets returned to you and displayed spatially in the GIS visualization window. So here's some other ones. How many states have a population greater than 1 million? How many counties had greater population in 1990 than in 2000, or whatever years you want? How many customers have last names beginning with Mac or Mick? So anything that you can basically structure as a sentence question that you can then transform into a query using the interface that we have available to us. That's one of the ways that we can get information out of vector data sets and table information. The interface that we use for that is based upon SQL, or structured query language. And this is something that's used in a lot of different databases, some version or another of SQL, or it's pronounced SQL. by people who use it quite often. If you learn how to write SQL statements, which are basically queries of your database, you'll be able to use that same logic and syntax of queries in multiple programs. Some queries you can save and reuse them again depending on how the program is set up. They're nearly always going to be case sensitive, so capital letters count, or lowercase counts in the structure of a language based query if you are using text based variables. So, for example, if you have a column with people's last names, the case will count whether it's capitalized or not when you structure a query looking for people with certain last names. So here is the graphic interface for SQL, creating SQL statements in ArcMap. We're selecting by attributes, and the drop down is we're creating a new selection from POP 2010, and the lower part of that diagram is showing us, or that figure is showing us the SQL statement. So we're selecting from counties the data set where the variable POP 2010 is greater than 500,000. So what we get as a return from the table will be all the counties in that variable that have an entry for it that are greater than 500,000. Over on the right, some examples of queries from a variable. So again, POP 1990, greater than or equal to 500,000. So every entry from the city's data set that matches that will be the return. The second one, selecting from a county's data set where the value of beef cow underscore 92 is less than beef cow underscore 87. So where we have a reduction in the number of that variable 92 compared to 87. A third one, selecting from parcels where the land use code equals 42 and the value is greater than 50,000. So the returns we're going to get must meet both of those conditions. And the last one in the examples here, selecting from a variable or data set known as rentals, where the rent is greater than 700 and rent is less than 1,500. So we're looking for a range of values, and everything that meets within that range is going to be returned. When the variable contains text information, case is important. So Smith with a capital S does not equal Smith all caps. Those would be two different entries in a variable that might be last name. So those would be two different last names, even though they're spelled the same with letters. The case is different, so they're different different individual things you'd have to search for in order to get them to come out from the SQL statement. When we're using multiple criteria, as we saw on the last slide, and or work differently. State equals Alabama or state equals Texas will give both Alabama and Texas. Value greater than 5,000 and value less than 10,000 must meet both conditions. So it must be between 5,000 and 10,000. Okay, and so each time you repeat a field, you have to repeat it in the SQL statement. So you can't say state equals Alabama or Texas. The SQL interpreter won't know what that means because you didn't specify a variable or column name. So it has to be state equals Alabama or state equals Texas. You have to declare the field each time you're using it in your query. If you're looking for something you're not quite sure exactly how it's spelled, but you know part of it, and it's text, you can use a wildcard. So you can fit into your statement looking for a wildcard using asterisk. The example here from the previous slides would be, we're looking for a last name. We know it's Mac something or other. MacDonald could be spelled with a capital M-A-C or a capital M-C. And so we use the wildcards surrounding it to say, find me all the names that are like that. Or numerically, find all the zip codes beginning with 0. So 0 asterisk in the SQL statement will give you all of the values that start with 0. So that's kind of a powerful thing that you can use to search a database if you're not quite sure what you're looking for at first to help narrow things down. Okay, so we substitute for the asterisk the actual command that's used in ArcGIS, the percentage sign. So name like percentage %D will find everything in the column that has that set of characters, the parenthetical, capital D, parenthetical. So the percentage is your wildcard character. It ignores all the other variations of capital D because they don't match exactly what that is. If you're looking for the second example, name like new whatever, New Hampshire, New York, new space is the actual search term, surrounded by the percentage signs as wildcards. So you'd get New Hampshire, New York, but not Newcastle or Kennewick as the things using the like operator. So name like this, or whatever variable it is, like that. That's another way that you can search text-based information. So as you know, when you form a query and apply it to a data set or data sets, what you're going to get will be all the records that meet those search criteria. And then while those records are highlighted, whenever you do other operations on that table or its data set, they're only going to be using those selected records. They're going to ignore the other ones. So you're going to want to be careful about that. When you make a selection, you might be intending to do an analytical routine just on that selection, and that's great. But if you intended to do it on the entire data set, you're going to need to deselect all of the selected records before you continue. When things are selected, so for example, if you made a selection out of a table, you can export those selected records to a new table and data set by using the export function. You can calculate statistics on just the selected records alone if they're numerical. You can calculate new records, new values for those selected records using the ability that you can do that in the GUI field calculator. Or you can produce reports based on those records using the interface. So querying is a very useful portion of ArcGIS, getting at spatial data through the table and accessing the information in the table in order to select the spatial components and then visualize them, or use those spatial selections then in further analytical steps toward whatever the project is designed to do, or the questions that you're trying to answer. So that's the end of this lecture. The next one we're going to look at vector analytical techniques in more detail.